the first thing that I would do is simplify to rewrite this radical. So we have 12x cubed, x to the 1/2 dx. And then remember that when you are multiplying exponential expressions together, you add their exponents. So to simplify, because we have an x times another variable x here, we can add the 3 plus 1/2. The 3, of course, will get a common denominator of 2/2. So that gives us 6 plus 1, so we get 7/2. So this is just the simplification process. We have not actually taken an integral yet. So this will become 12x to the 7/2 dx that we are trying to integrate. Now, the 12 is just a constant coefficient, so that tags along. For the actual integrate step, what we'll do is we'll add 1 to the exponent, divide by the new exponent. So we'll add 7/2 plus 1, get a common denominator of 2/2. So that gives us 9/2 as the new exponent. So this will be 9/2, and then divide by the new exponent, or flip immediately. So that's plus c. So then, because we have a fraction in the denominator, we are going to flip this denominator fraction. And what I usually do when I flip it is I kind of sandwich it in between this 12 and this x expression. So it's going to be 12, flipping 9/2 is going to be 2/9, and then x to the 9/2 plus c. So if you look at simplifying this, the 12 and 9 have a common factor of 3. So if I take that out, if I take a factor of 3 out from 9, I'm going to be left with 3. Taking a factor of 3 out from 12, I'll be left with 4. So that's going to give us, when we multiply fractions straight across, 4 times 2, so 8/3, x to the 9/2 plus c. Now, if you wanted to, you could rewrite that in terms of a simplified radical expression. However, it is not required to do that. So you can just leave your answer like that, and that is perfectly acceptable because you integrated and you simplified the fraction.